Hello class, welcome to Unit 6, Video 2. Today we're going to go ahead and look at right triangle trigonometry. Your learning target is that you can identify and apply right triangle trigonometry functions. So the functions I'm talking about are sine, cosine, tangent, stuff that you've seen before in geometry. So the Americans with Disability Act provides regulations designed to make public buildings accessible to all. Under this act, the slope of an entrance ramp designed for those with mobile disabilities must not exceed a ratio of 1 to 12. This means that for every 12 units of horizontal run, which you can see in the picture, so 12 units of horizontal run, the ramp can rise or fall no more than 1 unit. Okay, so 1 unit. What we need to do is we want to figure out, well, what is the length of the ramp if you have a 1 to 12 ratio? Okay, if we're talking about finding the length of the ramp, this would be side x. Okay, so to find the length of the ramp, right now I have two sides and I need to find my third side, so I can just go ahead and use Pythagorean theorem. So I would have 1 squared plus 12 squared equals x squared. Well, this is 1 plus 144 is equal to x squared, so I have 145 is equal to x squared. To solve that, take the square root. So x is equal to the square root of 145, and if we're talking about in terms of a real life situation, somebody's going to want you to say, well, what is the square root of 145? So on our calculator, we would do second square root, which is above your x squared, 145. So it's 12.04. This 5 tells me to make this a 2. So 12.042 feet. So the length of the ramp is 12.042 feet. So that's using Pythagorean theorem, which we talked about in our last video. Now we need to go ahead and find the measure of angle A. Okay, so here is angle A, and I'm trying to figure that out. Well, this one you're going to need to use a trig function, either sine, cosine, or tangent. So what I need to do is figure out, well, what is every side? We always know the longest sides are hypotenuse, okay, but we don't want to use that piece of information because it wasn't originally given to us. We found that one. We want to use the information of 1 and 12 to figure out angle A. So what we need to do is label our sides. Remember, opposite, adjacent. So if this is the angle I'm looking at, my opposite side's across. So this is opposite. The next one next to it is your adjacent. So which trig function uses opposite and adjacent? So I have so, ka, toa. So you have to think back to geometry. So sine uses opposite and hypotenuse. Cosine uses adjacent and hypotenuse. And tangent uses opposite and adjacent. So this tells me I need to use tangent. So it's always tangent of the angle, we're calling it angle A, is equal to my opposite, 1, over my adjacent, 12. Okay, we need to figure out the angle. Whenever you need to figure out the angle, you use the inverse on your calculator. So A is equal to tangent inverse of 1 over 12. Okay, so let's do that on our calculator. There is one thing you need to do first if you're using your calculator. Make sure you're in the proper mode. Okay, so we want to find our angle in degrees, so go to mode. And currently mine's in radians. You'd want to make sure yours is in degrees. So if you are in radians, you just go over to degrees, hit enter, and then we can go back to our main screen. So second, quit. We'll get us back to the main screen. So if I want to find tangent inverse, I go tangent inverse is above tangent, so it's second tangent, 1 divided by 12. And this tells me angle A has to be 4.76. This 3 tells me to round up to 4 degrees. Okay. So angle A has to equal 4.764 degrees in order to be in regulation. Okay. So that is our little example. Now let's go ahead and refresh our memory a little bit more on sine, cosine, and tangent. So thinking back to what you learned in geometry, you can find missing sides or angles of right triangles using the 3 trig functions, sine, cosine, and tangent. The trig functions, sine, cosine, tangent, this is how you spell them out. Sine is abbreviated SIN, so we still say sine, but we write sin. Cosine is COS, and tangent is tan. Okay. So some trig function stuff. Okay, sine, remember, is your opposite over your hypotenuse. Tangent, sine's opposite over hypotenuse. Cosine's adjacent over hypotenuse. Tangent is opposite over adjacent. Okay, and the way we remember these things is by our SOHCAHTOA. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. Okay, so use that to help you remember them. And we're going to use this triangle here to figure everything out. Biggest thing is the longest side, which is across from your right angle, is always your hypotenuse. Okay, and then these two things that are left are what we call legs of our triangle. Once you know which angle you are looking at, then you can be more specific about which one's your opposite, which one's your hypotenuse. So if you look at this one, notice how it says sine of A, cosine of A, tangent of A. That tells me I'm looking at angle A. If I'm looking at angle A, the side across from it is your opposite. Then our hypotenuse we always know, and the one that's left is our adjacent. Or adjacent means next to, so it's the one next to the angle, so touching the angle. Okay, so sine of A. If we're looking at A, let's go ahead and figure it out for this triangle. We want opposite over hypotenuse. My opposite would be A, and my hypotenuse would be C. So it's A over C. If we're doing cosine of A, it's adjacent over hypotenuse. So the side next to, and then my hypotenuse. So it's B over C. Lastly, tangent is my opposite, which is A over my adjacent B. So A over B. So those are our basic trig functions. Then we need to talk about the reciprocal functions. Well, what is reciprocal? If I ask you to tell me what's the reciprocal of 3 over 4, the reciprocal is 4 over 3. So the reciprocal functions means you just flip it. Okay, so the reciprocal function of sine of A is going to be C over A, or hypotenuse over opposite. So just everything flips. Okay. So the reciprocal for sine is cosecant, spelled CSC. So it becomes hypotenuse over opposite when we flip it. And if we're looking at our triangle, it becomes C over A. And this is really just the reciprocal of sine, so it's 1 over sine of A. Cosine's reciprocal is secant, so we flip it, and this one's going to be hypotenuse over adjacent, so now it's C over B. And this is really 1 over cosine of angle A. The last one's easier to remember, cotangent. It's the reciprocal of tangent. So now we have adjacent over opposite, or in this case, A over B, and it's the reciprocal of tangent. Okay. Some people struggle remembering who goes with sine. Look at how there's a C and an S. And here, there's an S and a C. So they're reciprocal, so they need to flip the front letter. Maybe that's how you want to remember it. You flip it. So there always has to be a C and an S together and a C and an S together. And then when you get down to cotangent and tangent, I feel like they're just easier to remember that they're a pair. But cosecant and sine and secant and cosine belong together for reciprocal functions. So, SOHCAHTOA, find the values of the 6 trig functions for angle theta. So we're looking at angle theta. Let's just label our sides right away. If I'm looking at theta, the one always across is your opposite, because it means it's the opposite of the angle. That makes this one across from my right angle my hypotenuse. And over here I got my adjacent side. So if I'm finding sine, opposite over hypotenuse, my opposite is 4, my hypotenuse is 5, so it's 4 over 5. Cosine, adjacent over hypotenuse, so 3 over 5. My tangent is my opposite over my adjacent, so opposite over adjacent, so it's 4 over 3. Now, all of these are my reciprocals. So cosecant's the reciprocal of sine. So sine was 4 over 5, so cosecant is 5 over 4. Cosine was 3 over 5, so secant is 5 over 3. And tangent was 4 over 3, so cotangent is 3 over 4. So those are my 6 trig values. So example 2 says, if cosine of A equals 2 over 5, then find the value of tangent A. Okay, for a problem like this, we want to go ahead and draw a picture. The picture would be a right triangle. And I'm going to label this side angle A. Cosine now, adjacent over hypotenuse. So that means my adjacent is 2 and my hypotenuse is 5. So if I label this one across from my A as opposite, then across from my right angle is my hypotenuse, and my other one is my adjacent. Based off the information given, my adjacent side is 2 and my hypotenuse is 5. I want to find the value of tangent, which is opposite over adjacent. Currently, I don't have my opposite, so how could I find it? Well, I have a right triangle and I know 2 side lengths, so I can go ahead and use Pythagorean theorem. So it's going to be 2 squared plus, we don't know, so x squared equals 5 squared. So it'd be 4 plus x squared equals 25. If I subtract it, I get it's the square root of 21. Okay, so this is square root of 21. There's no perfect squares in there, so I can't simplify it all. So to find my answer, which we want the tangent of A, my answer of tangent of A will equal opposite, which is square root of 21, over my adjacent, 2. So this is my final answer for example 2. If you have any questions on that, please let me know. Otherwise, let's go ahead and try another one for example 3. I'm going to move it to the next slide. So if you want to take a look at example 3. So it says if tangent of B is equal to 3 over 7, find the value of sine of B. So tangent, if we write our SOHCAHTOA up here, tangent's opposite over adjacent. So I'm going to start out by drawing another triangle. That's not any better, but this is supposed to be a right triangle. If this is labeled angle, let's go ahead and label this one angle B. Now, my opposite in this case is over here. My hypotenuse is across from my right angle, and this would be my adjacent. Okay, so TOA is opposite over adjacent, so that means my opposite side is 3, my adjacent side is 7, so this is 7, and this is 3. We want to find sine, so I need to find my hypotenuse. So I use Pythagorean theorem. So I have 3 squared plus 7 squared equals x squared. So this is 9 plus 49 equals x squared. So I have 58 is equal to x squared. So x is equal to the square root of 58. Okay, so this is the square root of 58. And I would look and say, is there any perfect squares in 58? And there is not. So then I need to find sine of B. Sine of angle B. Sine is opposite, so 3 over my hypotenuse, square root of 58. It's not proper to leave that radical in the denominator, so we need to rationalize. So I multiply by square root of 58 on the top and the bottom. So I get 3 square root of 58 over 58 times 58 would be 58 squared. And then remember, my square roots and my square cancel, so it's 3 over 58 3 square root of 58 all over 58. So my answer for this one would be sine of B equals 3 square root of 58 over 58. Okay. Moving on to our next example, we have to solve for x. Okay. Now I look at this one and right away I'm like, oh, Pythagorean theorem. Can I do Pythagorean theorem? You need to have 2 sides. I only have 1 side, so I know I have to use sine, cosine, or tangent. So I'm looking at this angle. I say across from it is my opposite, and always across from my right angle is my hypotenuse. So I evaluate which trig function can I use. Who uses opposite and hypotenuse? Sine. So it is sine, and you always write the angle, so sine of 20 degrees is equal to your opposite x over your hypotenuse 15. We are trying to solve for x, so in order to get x by itself, I'd multiply both sides by 15. So x is equal to 15 sine of 20 degrees. So I take out my calculator, and we already made sure it's in degree mode, so if you didn't do that earlier, make sure it is in degree mode. I would clear it out. Sorry, I'm just going to clear my screen, and I would do 15 times sine of 20. And I would hit enter. And so this tells me x is a side length of 5.130, because this 3 tells me to stay the same. So x equals 5.130, and it's not labeled in any unit, so I can just leave it like that. Okay, that is example 4. Let's go ahead and look at example 5. Okay, it says solve triangle XYZ. Okay, if I ever tell you to solve a triangle, that means find all the values of all the sides and angles we don't know yet. Okay, so maybe let's start with the easiest one. Look at, I have this angle, but I don't have this angle. So angle Y. Well, how many angles are in a triangle? 180. So I need them all to add up to 180. So I would do, to figure out angle Y, maybe I'm going to go like this. Angle Y, I would take 35 plus 90 plus Y, and that has to equal 180. Okay, so if I take 35 plus 90, I get 125 plus Y equals 180. If I subtract 125, 180 minus 125, I get that Y is 55 degrees. Okay, so that's my first thing that I had to solve. So angle Y equals 55 degrees. So I have all my angles solved for. Now let's go ahead and solve for my sides. Let's just start with X. Okay, let's use information that they gave you in case you made a mistake. So we know this angle, okay, and this would be my opposite. Across from here would be my hypotenuse, and here would be my adjacent. Using what they gave us the 35 and the 10. Okay, if we're trying to find x, that means we're using adjacent and hypotenuse. So who uses adjacent and hypotenuse? Cosine. So it's cosine of the angle, 35 degrees, is equal to my adjacent. Sorry, I messed that up, didn't I? We're using opposite and adjacent. We're not using our hypotenuse right now, so let's go ahead and change that. That is not cosine. Who is that? That is our tangent. So we're going to use tangent. So it's tangent of 35 is equal to my opposite x over my adjacent 10. So to solve for x, I multiply both sides by 10. So x is equal to 10 times tangent of 35. And I go ahead and type that in on my calculator. 10 times tangent of 35. We round to 3 decimal places, so here's 3. This 0 tells me that the 2 stays, so it's 7.002. So x equals 7.002. Okay, there's my x. I have my angle y. The last thing I need to solve for is z. All right, so now I have my hypotenuse. I'm still going to use the side I had before, and I'm using this angle. So who uses adjacent and hypotenuse? That one is cosine. So it is cosine of our angle, 35, is equal to my adjacent, 10, over my hypotenuse, z. All right, this one requires a little more work, and some people get confused by it, but it just is an extra step. Z is in the denominator. I can't solve for z when it's in the denominator, so I multiply both sides by z. So what I really have is z cosine of 35 equals 10. If I want to solve for z, I need to get rid of cosine. So I divide both sides by cosine of 35. So z is equal to 10 divided by cosine of 35. So I go to my calculator, and I'm going to take 10 divided by cosine of 35. Make sure you end the parentheses on this one. And we get 12.207, and since there's a 7 after, it tells me to round up to 2.08. So my z is equal to 12.208. So I have all three angles, and now I have all three sides, so this triangle is completely solved for. Okay. We're going to switch gears to finding angles. So if you have any questions so far on trig, please write them down or come and ask. Otherwise, let's move on to finding some angles. Okay, it says solve for x, so it's an angle. So we're going to use the same idea we did before to set it up. Okay, let's look at what sides I have. Well, across is my opposite, which I do not have. And this one's my hypotenuse. And this one's my adjacent. Okay, there's nothing over here. So I know I have to use my hypotenuse and my adjacent. So who uses hypotenuse and adjacent? Cosine. So it's cosine of the angle equals my adjacent, 16 over my hypotenuse, 25. Whenever you need to find an angle, you need to use the inverse. So x is equal to cosine inverse of 16 over 25. Okay, so I type that one in on my calculator. We have cosine inverse, so to get there you go second cosine of 16 divided by 25. And that tells me my angle is 50.208. This one tells me the 8 can stay the same degrees. And that is how you find an angle. Biggest thing to remember is that if you're finding an angle, you need to use the inverse. Okay? 7, we're also finding the angle. Let's look at what sides we have this time. Here's my angle. We're going across, so I have my opposite. And across from my right angle is my hypotenuse. So looking at SOHCAHTOA, who uses opposite and hypotenuse? Sine. So it's sine of x is equal to 10 over 12. To find the angle, I do sine inverse of 10 over 12. And if I do that on my calculator, I go second sine, that'll give me the inverse of 10 divided by 12, which gives me 56 point, I'm rounding to 3. This 6 tells me to round this up to a 3. So 443 degrees. 56.443 degrees. Okay. And that is it for finding angles on this example. Okay. So we have 2 more word problems. Let's go ahead and take a look at those. Number 8. In order to construct a bridge, the width of the river must be determined. Okay, suppose a stake is planted on one side of the river directly across from a second stake on the opposite side. Okay, so what they're saying is we have a stake here and we have another stake here. Okay, they're directly across from each other. Then at a distance 50 meters to the left of the stake, so that means they're walking to the left and they walk 50 meters, an angle of 82 degrees is measured between the 2 stakes when they're looking at this stake. And here, it's 82 degrees. Find the width of the river. Okay. This one was nice and drew you a picture. Okay. If there is not a picture, please draw yourself a triangle and fill in the information. So let's see, how would you solve this? Well, this is my opposite. This is my hypotenuse, which doesn't help me. There's no information there. And this is my adjacent. So who uses adjacent and opposite? Adjacent and opposite is our tangent. So I'm going to have tangent of the angle, which is 82, equals my opposite, which is W, over my adjacent, which is 50. So to solve for this, I would multiply both sides by 50. So W equals 50 times tangent of 82. Typing that in, we have 50 times tangent of 82, which gives us 355.768. This 4 tells me that it stays the same, so 768 is what it will be at the end. So the width of the river is equal to 355.768, and this is being measured in meters. So 355.768 meters. Example 9. John found 2 trees directly across from each other in a canyon. Okay, so this is my canyon. John found 2 of them directly across from each other. So here's a tree, and here's a tree. When he moved 100 feet from the tree on his side, so we don't know what side he is, I'm just going to draw John here. He moved 100 feet away from his tree. On his side, parallel to the edge of the canyon, so it means he was walking the same direction as canyon. The angle formed by the tree on his side and the tree on the other side was 70 degrees. So when he's looking at this tree, this is an angle of 70 degrees. So this is where John is now. Find the distance across the canyon. So we are trying to find this distance. I'm going to call it D. Okay? You're going to have a problem like this, so make sure you feel comfortable setting this one up. So once again, I'm going to label everything. This is my opposite. This one is my adjacent. So who uses opposite and adjacent? Tangent. So it's tangent of 70 degrees equals my opposite D over my adjacent 100. So to solve for D, I would multiply both sides by 100. Let's go up here. So D equals 100 times tangent of 70. Typing that into our calculators, 100 times tangent of 70 gives us 274.74. This is a 7, but this 7 tells us to round it to 8, so 0.748. And this one's measured in feet. So the distance across the canyon is equal to 274.748 feet. Okay. So that will do. That will be it for the notes for Unit 6, Video 2. If you have any questions on the trig, please let me know. Otherwise, have a great day, and I will talk to you later.